Hi, in this video we're going to be talking about the Pythagorean Theorem. Now I know that you've had Pythagorean before in other classes, so some of this will be review, but I'm sure everybody needs a little bit of review of how it works. Okay, the formula for Pythagorean Theorem is a squared plus b squared equals c squared. The important thing to remember about a squared plus b squared equals c squared is that the c is always the hypotenuse. And remember, the hypotenuse is the long side of a right triangle. And the a and the b are the legs of the right triangle. And so the a and b really don't matter. It doesn't matter which one you call a and which one you call b. But you have to call the long side, the hypotenuse side, c. Another thing I should have mentioned is that you use Pythagorean theorem for right triangles. You don't use it for triangles that are not right triangles. Okay, so if you know two sides of a right triangle, using the Pythagorean theorem, you should be able to find the third side. So here's an example. So we've got side A is 5, side B is 6, and we're looking for side C. So first, you take the formula, which you can see written under step 2, and in place of the A and the B and the C, you fill in either the numbers, or you can fill in an X, or in this case, you could have even filled in the letter C. So we've got 5 squared plus 6 squared equals X squared. Then you're going to take the numbers that you're squaring and go ahead and square them. So that turns into 25 plus 36 equals X squared. And then the last step, you're going to add those numbers together, so you've got X squared equals 61. And then if you remember, in order to get X by itself, you need to square root both sides. And so you're going to take the square root of both sides. And by doing that, the square root of X squared is X. And then the square root of 61 you can either do on a calculator and get a decimal answer, or in some cases you can just leave it square root of 61. It depends on the worksheet or the quiz, whatever the question is asking for. I'm just going to leave it as square root of 61. Okay, here's another example. Find the length of the missing side. Oh, in this case it does say to 2 decimal places in this example. Okay, so we've got the 2 and the 2. First we need to determine whether the 2 and the 2 are the A, the B, or the C. And so remember the legs are A and B. So in this case I'm going to call the side with the 2 on the left A. I'm going to call the bottom B. And so I'm looking for side C. Okay, so now I'm going to plug them into the formula. A squared plus B squared equals C squared. So that's going to be 2 squared plus 2 squared equals C squared. Okay, so 2 squared is 4. So I've got 4 plus 4 equals C squared. Okay, 4 plus 4 equals 8. So now I have 8 equals C squared. And then the last step is, in order to get the C by itself, I need to square root both sides. And that's going to make the left side turn into C. And the right side, I'm going to plug it into a calculator and get the square root of 8. Okay, the square root of 8, when I plug that into my calculator, is 2.8284. But I'm supposed to round it to 2 decimal places. And so that would be 2.83. So my answer is 2.83. Okay, here's another one. Find the length of the missing side to 2 decimal places in this example. Okay, so this time I have the A is the 2, and that 6 we'll call that B, and again the missing side is C. Later on we'll get to some examples where we're looking for one of the legs. So again, a squared plus b squared equals c squared. So 2 squared plus 6 squared equals c squared. That's going to become a 4 and a 36. So 4 plus 36 equals c squared. So if 40 equals c squared, my answer is going to be the square root of 40. And so if I put that in my calculator, the square root of 40 is 6.32. So that's the length of this missing side. Okay, here's one where we're looking for a leg. Okay, so you can see this time the 7 is the hypotenuse. So this time the 7 is going to be the C. And it doesn't matter whether you call the 4 A or B. I'm going to be consistent with what I've been doing and call that the 4 centimeter side A. And I'm looking for B. So now if I plug the numbers into the formula, I've got 4 squared plus b squared equals 7 squared. Next step, I'm going to turn those numbers that were squared into regular numbers. So 16 plus b squared equals 49. You can see the difference now is since the 16 and the 49 are on opposite sides of the equal sign, I need to get the b squared by itself. So I need to subtract 16 from both sides. And that's going to leave me with b squared equals 33. Okay, so I'll square root both sides and put it into my calculator, and I get the square root of 33, which is 5.74. Okay, and there's my answer. Okay, now we've got some different pictures that are a little bit harder to figure out. Now some of the information behind this picture, there are going to be some things that you learn later on in this course, some rules about rectangles and some rules about angles that will prove to you why this right triangle that you see down in this area, why it's the same as this right triangle. And you'll also see that this side, where I'm putting the squiggly line, is the same length as the one that we're looking for with the centimeters. It looks like it in the picture, so I guess for now you're just going to have to kind of go with your instincts. But again, there are ways to prove that if this right half of the bottom side is 5, that this side over here is also 5. And also it looks like this side that comes down from the middle, it looks like it's about half of the height of the rectangle. You can see over on the left that the height of the rectangle is 4 centimeters. So if you were to guess that this is 2, you would be correct. And again, there are some rules that you'll learn later in the course to show that that is true. So we're going to go 2 squared plus 5 squared equals c squared. Because this is the right triangle we're looking at, and so the one we're looking for is side C. So 4 plus 25 equals c squared. 29 equals c squared. And the square root of 29 is 5.39. Okay, so that's a little bit trickier of a picture. We've got one more that's sort of like that. Okay, here's another picture that makes you think a little bit. It's not quite as tricky as the last one. In this case, we just have a big rectangle that has a diagonal drawn through it that goes from one corner to another. And this time it's a little easier to figure out because you know with a rectangle, whatever the top side's length is, the bottom side is the same. And so we know that the bottom of this is 8 centimeters. And so again, we're looking for side C because the A will be the 3 and the B will be the 8 centimeters. A squared plus B squared equals C squared. We're going to go 3 squared plus 8 squared equals c squared, because we're looking for side c. So 9 plus 64 equals c squared, and that adds up to 73. So the answer is going to be the square root of 73. And that comes out to 8.54. Okay, so that was a picture that was a lot easier to understand. Here's the most difficult picture that we have to figure out, and there's a number of steps you need to go through to figure out how to get this. Well, first of all, this side that we're looking for, it's part of several triangles. Eventually, it's this one here that I'm drawing, that I'm outlining, is the one that we're eventually going to use to find that side. You can see it's the hypotenuse of that one. We can get the top side of this right triangle that I drew by noticing that we have a square in the top right corner, and if the side on the very top is 2, then the side below it is also 2 centimeters. So the top part of this is 8 centimeters from there to there. Okay, and then the other side we need to get is this side over here. The only way to get that side over there is to do another Pythagorean theorem to find that missing side. So we're going to take this right triangle, this small one on the right, and we're going to first find the missing side to that one, and then use that for ours. And so on the little right triangle on the right side, this would be side B. So we're going to go 2 squared plus b squared equals 4 squared, because the hypotenuse of that small right triangle is 4. So that would be 4 plus b squared equals 16. Now if I subtract 4 from both sides, I get b squared equals 12. And the square root of 12 is 3.46. Now I can take my larger right triangle, and remember that the sides of that the top of that one is 8, so that can be the 8, we can call that A, and again we'll call the 3.46 B, and we're going to look for C. So I've got 8 squared plus 3.46 squared equals C squared. So it would be 64. And then the 3.46 squared is back to 12 again. So plus 12 equals c squared. 64 plus 12 is 76. And then the square root of 76 is going to be my answer. And that is 8.72. So that one took a lot of steps and a lot of thinking to come up with the answer. Okay, so that's it for examples of how to do Pythagorean theorem. There is one more rule that we're going to talk about quickly here, and that is that you can also use the Pythagorean theorem if you know all 3 sides of the right triangle and you want to know if it's a right triangle, an obtuse triangle, or an acute triangle. Okay, so what we're going to do is plug the numbers into the Pythagorean theorem. If everything equals out, if a squared plus b squared equals c squared, then it's a right triangle. If c squared is larger than a squared plus b squared, so one way I always think of obtuse triangles is that the c is too big. Okay, so if the c squared is too big, that means that the c is too big. And so if you think of a triangle where the c is too big to be a right triangle, then it's going to look something like this, that the c side is going to be too big for it to be a right triangle. So that's the way I always remember that when the c squared is too big, that must mean obtuse. And so for the acute triangle, that is when the c is too small. Okay, so let's try a couple. If we go with this 2, 10, and 11. Now the C has to be the longest side. So if we set these up, actually I'll go through and set all three of them up first. So we'd have 2 squared plus 10 squared, and we're going to compare that to 11 squared. The second one, they're out of order, so be careful. 5 squared plus 7 squared, and we're going to compare that to 13 squared. And then the last one, we have 6 squared plus 8 squared, and we're going to compare that to 10 squared. So let's convert them into numbers. So we have 4 plus 100. We're going to compare that to 11 squared, which is 121. So we've got 104 on the left. We've got 121 on the right. So the C squared is too big. And so that means this one must be obtuse. Okay, the second one we have 25, and we've got 49. And on the right side, 13 times 13 is 169. So the left side, 25 plus 49, adds up to 74. And now we've got 74 on the left and 69 on the right. So again, the right side is too big. And so again, this one would be obtuse. Okay, the last example, you've got 36 plus 64 on the left side and 100 on the right side. So the left side turns into 100 and the right side is 100. So this time they're going to equal each other, and so this time it must be a right triangle. Okay, so those are some rules about Pythagorean theorem and some examples. If you have any questions, please ask in class.